Write an assembly language program to find the product of two numbers stored in memory location C005 and C006. The answer is stored in memory location C000. Now this is just an 8-bit answer to explain multiplication in its simplest form. We can approach this problem in two ways. We multiply two numbers only by doing successive addition. So I could add 2 4 times, or I could add 4 2 times. So in my case, I will store the value in C005. I choose the first option. I take 4 and I put it in the counter register C. C is my counter register. And I store number 2 in the register B. And then I will add 2 to the value in the accumulator 4 times. So I keep track of this 4 times by just every time I do an addition, I decrement the value in the counter. So see now, after doing the initialization, A is 0, 0, B is the operand that will be successively added, C is the other operand which acts as a counter. I add 2 to the value in the accumulator. I reduce the value of C. Because C is greater than 0, I continue with the addition. Again, I will add 2 to the accumulator contents, which is 2 now, to give me 4. So this is my new value, 4. I continue because value in the counter register is not 0 yet. So again I do an addition. Okay, again I do an addition. After doing this addition, when I reduce the counter by 1, it becomes 0. So hence we stop the successive addition. So we'll continue doing an add B in our case as long as the value in C is greater than 0. So we approach this problem first by loading C005 into the register C. Now the choice of registers depends on you. Okay, I have used C to hold the value in C005 that acts as my counter register. You have only learnt LDA and STA that deals with data from memory locations, and then you use move to move the value from the accumulator to the respective register. In the future, we'll be learning some more instructions that help us move data from memory using memory pointers to registers. Now it's the same old instruction, LDA, okay, and then I move it to C by saying move C comma A. Fine. Now the second operand, I again do an LDA for C006. After moving this value in the accumulator, okay, I copy this value to the register B from A. Now I do my first addition, add B. Okay, I do my decrement C, and now I check. After the decrement, the 0 flag would be set if the value in C has become 0. If not 0, jump, not 0, to continue addition. I'll call the label continue. Okay, so continue, I write the same thing here to continue with a colon. Here I put no colon. When I use continue here, I put no colon. Okay, I forgot to initialize the value in the accumulator to 0. That's a very important step because A will be having a previous value in it. So you must initialize the value in the accumulator to 0. So move immediate A to 00H before you do the successive additions. Now, okay, this is my comment here. decrement the value in C. Okay, if C is not 0, you repeat the addition process. Now what we do? If C becomes 0, the 0 flag will set, hence it will not continue doing the successive addition and the decrement of C. It will flow down. It will flow down. So what we will do here? We will save the answer that's there in the accumulator to the memory location that we are asked to save, that is C000. And the last instruction has to be halt. Okay, halt as long as you are using the simulator. Once we go to the lab, we will be using RST1. So now let's prepare this program for trying out in our simulator or in the lab. I've just copied the entire thing here with the comments, with the instruction opcode and operand, and with the label. I've added the hex codes by referring to the appendix A on your textbooks. Just confirm these values. Just confirm whether MVI is really 3E. I may have made a mistake. Now the other thing that you have to notice, okay, I have kept for a 3-byte instruction like LDA, jump not 0, and STA, I have kept 3 rows. For a 2-byte instruction like MVI, I have kept 2 rows. Okay, so now let's fill those blanks. LDA has a memory location C005, so this will be the lower byte of the instruction, followed by the higher byte of the instruction. Again this lower byte of the instruction, followed by the higher byte of the instruction. Again this, what is the data for the move immediate A? 00. Fine. Jump not 0. Okay, I don't know what this memory location is. Okay, so we will enter it later. STA, the answer has to be stored in C000. So lower byte followed by higher byte. Now because the data ends at C006, let us save our programs starting from C008 after keeping C007 blank. Okay, so now let's do this. C009, C00A, C00B, C00C, C00D, C00E, C00F, C010, C011, C012, C013, C014, C015, C016, C017, C018, C019 and C018. Now this is what we have to fill in. Now continue is at memory location C012. So just write it here in brackets C012. Put the lower byte, put the higher byte. As I told you, in the lab, the memory locations and the hex code program is what you will feed in to your microcomputer, 8085 microcomputer. In the simulator, you do it differently. You type the assembly language program and you observe the hex code. Okay. So with this, after seeing the output, see that you put the answer here in C007. Note down the flag register contents and the general register contents.